We are now on to the last part of our work, power, and energy topic, which is, of course, power. So as per defined, power is the rate at which work is done. It is the work-time ratio. The quantity of work has to do with the force causing a displacement. However, work has nothing to do with the amount of time that is the force is acting to cause the displacement. Sometimes the work is done very quickly and other times the work is done rather slowly. To understand this better, let's have an example. For example, a rock climber takes an abnormally long time to elevate her body up a few meters along the side of a cliff. On the other hand, a trail hiker who selects the easier path up the mountain might elevate her body a few meters in a very short amount of time. The two people might do the same amount of work because they have traveled or displaced themselves at the same distance. Yet, the hiker does the work in considerably less time than the rock climber. The quantity that has to do with the rate at which a certain amount of work is done is known as the power. The hiker has a greater power rating than the rock climber because he or she elevated her body with the shortest amount of time. Remember that power is the rate at which work is done. It is the work time ratio. So in this formula, you're just going to divide work divided by the time in a certain scenario. Mathematically, it is computed using the following equation. Power is equal to work divided by time, or simply P is equal to W divided by T. The unit for power is what? So we write it as WATT. As is implied by the equation for power, the unit of power is the equivalent of unit of work divided by the unit of time. Thus, you can also write watt as joule per second. For historical reasons, some machines uses the term horsepower to occasionally describe power by a certain machine. Remember that 1 horsepower is equivalent to approximately 750 watts. So pag tinanong kayo how much horsepower does this machine does, you just have to divide it or multiply it by 750 watts. Most machines are designed and built to do work on objects. All machines are typically described by a power rating. Engine, refrigerator, a factory machine. The power rating indicates the rate at which that machine can do work upon other objects. Thus, the power of a machine is the work time ratio for that particular machine. A car engine, for example, is here on your screen, is an example of a machine that is given a power rating. The power rating relates to how rapidly the car can accelerate the engine can accelerate the car. Suppose that a 40 horsepower engine could accelerate the car from 0 miles per hour to 60 miles per hour in 16 seconds. If this were the case, then a car with 4 times the horsepower could do the same amount of work in 1/4 of the time. Ibig sabihin, mas mabilis niyang mapapa-accelerate yung car from 0 to 60. For example, in just 4 seconds, it can go from 0 to 60 na agad. That is a 160 horsepower. The point is that for the same amount of work, power and time are inversely proportional. The power equation suggests that a more powerful your engine is, the same amount of work can be done in less time. A person is also a machine that has a power rating. For example, this weightlifter here. Some people are more powerful than the other. For example, Heidelin Diaz, no, she can raise a heavy barbell with a shorter time. Tayo, kailangan pa nating maghingalo, no? Sobrang tagal. And minsan hindi pa natin kaya. So, it makes sense that some people are capable of doing the same amount of work in less time or more work in the same amount of time. A common physics lab experiment would involve quickly climbing a flight of stairs and using a mass, height, and time information to determine a student's personal power. So, dati ng face-to-face, magdadala ng gamit and then akyat baba sa hagdanan to compute for personal power. Despite the diagonal motion along the staircase, it is assumed that the horizontal motion is constant and all the force from the steps is used to elevate the student upward at a constant speed. Thus, the weight of the student is equal to the force that does the work on the student, and the height of the staircase is the upward displacement. So, suppose we have Ben that elevates his 80-kilogram body up to a 2-meter stairwell in 1.8 seconds. If this were the case, then we can calculate Ben's power rating. It can be assumed that Ben must apply a 800 Newton downward force upon the stairs to elevate his body. By so doing, the stairs would push upward on Ben's body with just enough force to lift his body up the stairs. This is the third law of motion. It can also be assumed that the angle between the force and the stairs of Ben and Ben's displacement is 0 degrees. With these approximations, Ben's power rating could be determined as power is equal to work over time. That would be 784 newtons multiplied by 2.0 meters divided by 1.8 seconds. The power would be 871. Let us write it down. So, again, let me repeat. Power is equal to work divided by time. If Ben have to accelerate his body for about 784 newtons in 2 meters, remember that this part here is the work formula. And the time would be 1.8 seconds. You put that in your calculator, you're going to have 871 watts. That is now the power rating of Ben. And sobrang, that would be 1 horsepower and all. Okay, to understand this better, let's check our understanding. Um, we have two P6 students, Will N. Abel and Ben Pump in Iron. They are in the weightlifting room. Will lift the 100-pound barbell over his head 10 times in 1 minute. Meanwhile, Ben lifts the same 100-pound barbell over his head 10 times in 10 seconds. Which student does the most work and which student delivers the most power? Then we have to explain our answer. Okay, I'm going to give you um, a few moments to think of your answer. Just explain it to yourself. Just digest it to yourself, and we'll try to confirm it in a while. Okay, so let's see what's our answer for this one. According to this, Ben and will do the same amount of work. Why? Because they have displaced the same barbell, 100-pound barbell at the same displacement. They apply the same amount of force to lift the same barbell at the same distance above their heads. Yet, Ben is the most powerful since he does the same amount of work in considerably less amount of time. Will, naangat niya 10 times in 1 minute, meanwhile Ben, naangat niya 10 times in 10 seconds. Power and time are inversely proportional with each other. Okay, I hope that's clear. Another would be this one. During a physics lab, Jack and Jill run up a hill. However, Jack is twice as massive as Jill. Yet Jill ascends the same distance in half the time. Who did the most work? Who delivered the most power? Explain your answer, giving you a few moments to think. Okay, let's check our answer. Jack does more work than Jill. Why? Because Jack must apply twice the force to lift his twice as massive body up the same flight of stairs. Yet Jill is just as powerful as Jack. Jill does one half the work, yet does it one half the time. The reduction in work done is compensated for by the reduction in time. Okay, so we're now going to proceed with some basic problem with regards to power. Let's have the first one. When doing pull-ups, an athlete lifts her 42-kilogram body at a distance of 0.25 meters in 2 seconds. Our question would be, what is the power delivered by the student's biceps? Okay, let me change my ink. So, to raise her body upward at a constant speed, the student must apply a force which is equal to her weight. Okay, that would be mass multiplied by gravity. The work done to lift her body would be work is equal to Fd, whereas F should be equal to the mass multiplied by gravity, or simply F grav. So the force would be mass, which is 42 kilogram, multiplied by 9.8 meters per second squared, that's acceleration due to gravity, multiplied by the displacement, which is 0.25 meters. 25 meters. Okay? Divided by, sorry, that's it. That's the work done. Okay. So the answer here would be about 102.9 joules. That's the work done. Going to power, so power is equal to the work time ratio. So since we have already searched for work, we're just going to plug it here. It's 102.9 divided by the time. That will be 2 seconds. So that's 2. So just plug that in your calculator. Your answer would be 51.5 watts or joule per second. Watts. This is already rounded, okay? So that is your answer. Next one. An escalator is used to move 20 passengers every minute from the first floor of a department store to the second one. The second floor is about 5.20 meters above the first floor. If the average mass of the passengers is 54.9 kilogram, what is the power requirement of the elevator in order to move the number of passengers, which would be 20, in this amount of time? Okay, so a good strategy here would involve determining the work required to elevate one average passenger. So hanapin muna natin yung amount of work for one passenger. And then, to find our final answer here, which is the power for the 20 passengers, we'll just have to multiply that into 20. Okay? So, multiply lang natin. Then, finally, the power can be determined by dividing the total work value by the time required to doing the work. Okay, so the solution would be work for one passenger would be equal to the same formula, F multiplied by D cosine theta. And then the force here, since it is being elevated, that the force would be F grav multiplied by displacement cosine theta. And our F grav or F gravity would be equal to mass multiplied by gravitational acceleration. So the average mass for one passenger is 54.9 as stated. So that would be 54.9 multiplied by 9.8, which is the acceleration due to gravity, multiplied by the displacement, which is 5.2 meters, 5.20 meters. Cosine theta, we don't have cosine theta because if this is an elevator, if the displacement is upward, the force is also upward. The angle between the displacement and the force is the same. So that would be 0. So no need to write it down. We can cancel. And cosine 0 would be 1. Okay. So multiply this. We're going to have about 2798 rounded joules. And for us to find W20, W20 is equal to work 1 times 20. So we'll just have to multiply this 2798 to 20. The answer would be 55954 joules. So this is now the work done for the 20 passenger. We're now going to search for power, and the formula for power is the rate of work over time. So that's WT. And our WT should be the 20 passenger because that's our question. So W20, that will be 55954 joules over the time. That would be every minute. Okay, so every minute, that would be 1 minute. Our constant would be in seconds, so this should be in seconds also. That would be 60. So divide that in your calculator. That would give you about 933 watts. So that's it. That's how you compute for the power in terms of work done in a certain amount of time. Okay. I think this would be the last part of our topic. Thank you so much, everyone. Everything would be uploaded in our Agham website.